So now I will give you a few examples how economics, psychology, neuroscience can be combined during the studies of decision making. We will not go into details today because in the follow-up lectures we will discuss the formal neuroeconomics models of this decision-making process, but it will give you an example how different approaches can be combined. So let's make a look to the famous experiment, one of the earliest neuroeconomics experiment conducted by Alan Sampley. So some of you know the very classical behavioral economics game, ultimatum game. Some of you perhaps do not know this game, that's why I will explain you quite quickly. Imagine that there are two players. So player one gets a sum of money, for example $100. Player one has to split this money in any proportion. So for example, the player one can offer only $1 to player two, who can split money equally. So there is no limitation. Player one can split money in any proportion. This game is played once and anonymously, so players do not know each other. Player two can either accept or reject the offer. If player two rejects the offer, nobody gets any money. If player two accepts the offer, they get money in the proportion suggested by player one. It's a very simple experiment, but it actually makes a lot of interesting predictions. According to the normative economic theory, player two in this situation has to accept any sum of money. Why? Because even $1 is more than zero. If player two rejects the offer, he gets or she gets nothing. That's why player two, in accordance with normative theory, has to accept any sum of money. Actually, in reality, people have a tendency to reject, in this case, the sum below 30%. So people react to the small sums as unfair offers. And this is something interesting and very surprising for normative economic theory. So people behave irrationally. So neuroeconomists suggested to make a look what happens in the brain when we get these unfair offers. And Alan conducted a very interesting experiment. So here you see brain activations, activity of the brain when subject face unfair offers. So you see different activities. Let's focus now on dorsolateral prefrontal cortex, DFPLC, and on anterior insular cortex. In neuroeconomics, we will meet these brain areas quite often. We will discuss the role, the functional role of these areas in details in the next lectures. But briefly, dorsolateral prefrontal cortex is related to the cognitive control, to the more rational decisions. Insular cortex is an emotional area in the brain. For example, this area is activated when we experience disgust or when we feel pain. Let's make a look to the activity of these regions when we face unfair offers. So Alan suggested that the relative activation of the insular cortex and dorsolateral prefrontal cortex can predict our decisions. If insular cortex is more active than dorsolateral prefrontal cortex, if emotional brain areas are more active than our rational brain areas, we reject the unfair offers. So if insular cortex, emotional area, is not active enough, we accept unfair offers. And what happens if we will temporarily shut down dorsolateral prefrontal cortex? This is our rational brain areas. So we can do it using transcranial magnetic stimulation. We will discuss these methods in details during the next lecture. But with magnetic pulses, we can temporarily inhibit activity of certain brain areas, for example, of the dorsolateral prefrontal cortex. And this experiment shows that if we temporarily shut down activity in the right dorsolateral prefrontal cortex, the acceptance ratio for the unfair offers goes up. So we start to accept unfair offers. So with neuroscientific techniques, we can detect brain activity reacting to the unfair financial offers. With neuroscientific techniques, we can manipulate activity related to our reaction to unfair offers and change our behavior. We can increase acceptance ratio, so people start to agree with unfair financial offers. Furthermore, we can investigate the evolutionary basis of our reaction to unfair offers. So, for example, we can study whether monkeys have an emotional reaction to unfair financial offers. So we can investigate capuchins, so they can trade small pieces of plastic coins for food. So in this case, this monkey exchange coin for biscuit. What happens if another monkey will also make this transaction, but instead of biscuit, we get a much more tasty grape? So our monkey can actually see that another monkey gets much more for the same coin. This is an unfair situation. Would monkey reject financial transactions in this case? And we will know it from our course, where the monkeys also have a reaction to unfair financial offers. If they do have, it would mean an evolutionary basis of our financial decisions. So for neuroeconomics, it is very important to combine various approaches. We should remember that our nervous system is not only a system that supervises our behavior. There is also endocrine system, and dozens of glands in our body produce hormones that modulate our decisions and our behavior. Two major systems supervising our behavior, endocrine system and nervous system. And they are quite different. So for example, nervous system is a hardwired system, because neurons are organized in more or less stable networks. But endocrine system is a wireless system, because glands produce hormones, inject hormones to the bloodstream, and blood distributes hormones around the body. Nervous system is quite fast system, so neurons can change our behavior in milliseconds. Hormone system, endocrine system, is much more slow. It takes seconds or hours to change our behavior. So there are two systems, but they both affect our decisions. So for example, very important gland is located on the basis of the brain. It is functionally connected to the brain. This is so-called pituitary gland. This gland, a posterior part of this gland, produces different hormones, including oxytocin. And oxytocin is a very important hormone for the decisions in social context. So oxytocin, or blood level oxytocin, affects our bonding with our partners, affects our sexual behavior, affects social relationship, affects sexual responses. And the level of oxytocin affects our trust during the financial decisions. So this interesting line of studies is related to the famous neuroeconomist Paul Zak. He investigates oxytocin quite a lot. He suggests that oxytocin is a hormone of peace. There are different views in the Society of Neuroeconomics about the functional role of oxytocin. But definitely oxytocin affects our decisions. And Paul Zak, together with the group of Ernst Ferch in Zurich, conducted a very smart experiment. They used a standard behavioral economics task called trust game. So in this game, two players are playing together, and player one, investor, gets 12 monetary units. She can invest 0, 4, 8, or 12 monetary units to the player 2, to the trustee. Whenever the sum is invested, this sum is tripled by the experimentator. So trustee gets additional 12, 24, 36 monetary units. And trustee can make a decision how to split the amount of money this person has at the end of the trial. So at the end, this person can have 12 monetary units if she doesn't get any investment from the investor, 24, 36, or 48 monetary units. And investor has to trust trustee, because trustee can keep all money. So it's an interesting paradigm that allows us to investigate trust of people. So if we will make a look to the distribution of the average transfer amounts across subjects who got oxytocin, and in this graph the results are indicated by the black lines, they give much more maximum investment decisions. So they much more invest all money to the trustee. So oxytocin can stimulate trust during the financial operation, during the financial decisions. So our endocrine system modulates our decisions. Of course, our genes also modulate our decisions. So I'll just give you one example. The study was conducted by Paul Zak with traders on the Wall Street market. And he found a correlation between different versions of the gene affecting the level of dopamine and their success on the market. He measured success as average years in the profession. And he found that the moderate level of dopamine related to the gene AA brings more success to the traders on the Wall Street compared to the version GG and GA. These versions of the genes are related or resulted in the higher level of dopamine in the brain. So as we will learn from this course, dopamine is very much related to our reward system and our risk-taking behavior. So it looks like you need a moderate level of dopamine in the brain and perhaps less level of risk-taking to be successful financial trader on the Wall Street. So this study provocatively shows us a link between our genotype, or the version of our genotype, and our financial decisions. So overall, neuroeconomics combines economics, genetics, biology, neuroscience, psychology together to build a unified theory of decision making. I will try to present you a general main concepts of neuroeconomics in the follow-up lectures. So during the next lecture, we'll discuss brain imaging techniques, but in the lecture 3, I will present you the main models of decision making. But before that, I would like to shortly discuss with you some philosophical aspects of decision making.